everybody. Now, we have two possibilities when going to work, right? If we go from, this is the question, right? If we go to work through 6th Avenue, things will happen. And if we take Dover Road instead, things will happen. All right? So let's create a Venn diagram, a tree diagram for this. And I'm going to write down the possibilities, the probabilities later, after I have all the rows. All right? So I'm going to call S for 6th Avenue, and I'm going to say D for Dover Road. All right? So I have these possibilities. First, I'm going to go to S or to D, right? That is the first option. And then I can go, no. That's first 6th Avenue and then Dover Road. Yes. Sorry. So this is not the tree diagram I'm looking for. First at 6th Avenue and then at Dover Road. Right? So I could get delayed here. I could get delayed or I could get on time. Right? Same with the other option. I could get delayed or I could get on time. I could get delayed or I could get on time. All right? This is going to be my tree diagram. Now that we have the diagram, we can write down all the possibilities. Look, we have two sectors. We have the sector of possibilities of getting delayed or getting on time through 6th Avenue. And we have the sector of getting delayed or getting on time, delayed or on time, through Dover Road, right? That is the tree diagram. Now, according to the question, if I go through 6th Avenue, I get delayed with this probability, 7/10. So that probability is going to go right here, getting delayed 7/10. Right there. Right? Beautiful. Also, we have another piece of information. At Dover Road, we get delayed with a probability of 3/5 at Dover Road. Right? Here. At Dover Road, we get delayed with 3/5. So if I go here, 3/5 or 3/5. Right? Beautiful. From here, we can complete the tree diagram. But how? How can we complete it? Just by remembering the properties of the tree diagram. We know that in each sector, the addition of the probabilities must be 1. So how much am I missing from 7/10 to become 10/10, to become a 1? Well, I'm missing 3/10, right? This plus this will give me a 1. Correct? Okay. So that is the first obstacle. The first obstacle. From here, let's complete this information here. 3/5, and this one will be 2/5. 3/5, so 2/5. Now that we have our tree diagram, that is the first obstacle. Now that we have our tree diagram, we can find the probabilities now. Let's look at the questions. The first one, find the probability that I get delayed only once. Only once. I can only get delayed once. So this option is not going to work, right? This option is not going to work because I get delayed twice. But this one works pretty well. Same as this one over here, right? I get delayed only once. Now, this one, on time and on time, doesn't work because I am not getting delayed, and I need to get delayed once. So these two are the possibilities that I care about. What are those probabilities? Pretty simple. We are going to multiply those options. So we have 7/10 times 2/5. This is 7 over 10 times 2 over 5. If I multiply these two by multiplying, we're going to have 14 over 50. Sorry, 14 over 50. That's it. We have one possibility. And what is the possibility, the probability of the second option? Well, this will be 3 over 10 times 3 over 5. This will be 9 over 50. So at the end of the day, the answer for question A, the answer will this be the addition of this, right? 14 over 50 plus 9 over 50. In other words, 25 over 50. Oh, but that one can be simplified, right? This is 1/2. Right? 1/2. Exactly 50%. I get delayed once. The probability that I get delayed once is exactly 50%. All right. Did I make a mistake? Let's see. No, 25. No, 23. This is 23 over 50. There we go. Now it is correct. No simplifications. 23 over 50. All right, that was the first question, right? Let's go for the second one, B. Find the probability that I do not get delayed at all. I do not get delayed at all. So, delayed, doesn't work. Delayed on time, doesn't work. On time, delayed, doesn't work. But on time, that's the answer, right? I do not get delayed at all, meaning I get on time on both. So this row here, the probability will be 3 over 10 times 2 over 5. So this will be 6 over 50. All right. So we have our probability for the question B. A little bit easier, right? 6 over 50. That thing can be simplified as well. We can simplify this one. This is 3 over 25. It is exactly the same. If during an examination you leave this as an answer, that is correct. Unless the question says simplify as much as possible. You have to be aware of those questions, all right? Beautiful. Let's continue with the third. Given that I get delayed exactly once, what is the probability that it was at 6th Avenue? And now we jump into the realm of conditional probabilities. Conditional probabilities. Take a look at this. No, I want to. I can show it to you. I can show it to you. Conditional probabilities. I don't have enough space, so I'm going to write it here. Conditional. There is a little formula that when we were working with Venn diagrams, we didn't use. The reason being, we didn't need it. We could just solve conditional probabilities by looking at the diagram, right? But now, we cannot just look. We have to use the little formula, all right? Here is how it goes. The formula is this. The probability of an event given that another one occurred, A given that B, probability of A given that B, right? In this case, B is our condition, right? B is our condition. And A is the one we are looking for. A will be our success. The formula says, this is a fraction. On top, we are going to have the probability of the intersection of both events. So we want both events to happen at the same time. A intersected with B. And down, we have the probability of the condition, B. That is the little formula. We are going to use that formula in here. We are going to use that formula in here. Now, if you guys like to take notes, go ahead and write it down in your notebook. If you just like to take pictures, take a picture, take a screenshot right now. This little formula, we are going to have to use it. Now, again, remember, this B is the condition. What is the condition? Whatever comes after given that. That is the condition. So that goes in here. That probability goes down in the denominator. That's it. I'm going to show it to you in an example right now. I'm going to erase this formula, and hopefully all of you wrote it down somewhere so that you can see how I use the little formula. But I am going to erase it because I don't have the space, all right? I'm going to erase it right now. Of course, if you just want to look at the book, that formula is in the book. If you go to the conditional probability part, the formula, it is right there. That formula is right there. Okay, so we want to find the probability of, what was that? Given that I get delayed exactly once, all right, so this is our condition. Given that I get delayed exactly once, this is our condition. So let's find out exactly this probability. I get delayed exactly once. Oh, look at that. I get delayed only once. Is this one? So it is the probability of A. We have it over here. The probability of us getting delayed exactly once is this one, 23 over 50, right? So in the denominator of our formula, we are going to have to write down 23 over 50. That is the probability of the condition. And we just said the condition was getting delayed only once, exactly once. So there you go, 23 over 50. 23 over 50. That is the probability in the denominator. Just like we did in the previous exercises of conditional probability, always please try to begin with the denominator, with the condition. Try to begin with that first. Beautiful. Now that we have our condition done, I get delayed exactly once. Let's try to find the other one. What is the probability that it was at 6th Avenue? What is the probability that it was at 6th Avenue? So I need to find the probability of getting delayed exactly once and it was at 6th Avenue. Let me show it to you in the board. Which of these rows shows me that I get delayed at exactly 6th Avenue? Here I get delayed, right? And this is 6th Avenue. So this row works. But which way do I turn? Do I go up for delayed again or do I go down for on time? The question says I get delayed at 6th Avenue, but remember the formula. On top in the little formula, we have an intersection. We have an we have an and, right? So we are looking for both things happening. We want only one delayed and that delay to happen at 6th Avenue. So the only option is this one over here, 14 over 50. In other words, 14 over 50 will be the possibility on top in the denominator. Now that we have our formula, all we have to do is do the mathematics. Now, the mathematics in this case, this doesn't really happen all the time, but in this case, we can cancel 50 and 50. The solution will be 14 over 23. Wait, 23. Let me write it here on top. C. 14 over 23. Again, if we take a look at the formula, fill in the denominator first. The denominator was the condition. And we know the condition is this one over here. We did it already, right? We get delayed only once. All right. Now, for the one on top in the formula, we have an intersection, meaning we want both things to happen. We get delayed only once, and the delayed happened at 6th Avenue. Because if I say I get delayed only once, this row can work and this row can work, but we want the delay to happen at 6th Avenue. So this delay cannot happen. In other words, this is the only option I have. So the success will be 14 over 50. 14 over 50. Work this out in a calculator. Put it in a calculator. Or like I did, cancel the denominators, 1550. The solution, 14 over 23. There you go. Yes.
And why we can't like just by seeing the diagram put in like the in the in the second avenue, not late and then late.
Second Avenue here.
Late, not late,
Not late.
and late at the second, the Sixth Avenue. Like to say they're
What?
late, but only one time in the Sixth Avenue. No.
No. What? Again? What?
We have the as you can see me, late, not late in the Dover Avenue, and then late in the Sixth Avenue. Therefore, there will be only one late, and in the Sixth.
I have no idea what you're saying. Sorry. All right, can you try it in Spanish? Maybe that make things a lot easier. Can you try it in Spanish?
Sí, sí. O sea, solo de vista en el diagrama te está, o sea, la pregunta te está diciendo que tienes que estar late, pero en el Sixth Avenue, ¿sí? La pregunta.
Ajá, ok.
¿Sí? Y solo puedes estar una vez tarde, entonces entonces tendrías que no estar tarde en la segunda. Entonces sería
Okay.
D y T.
¿Sería qué?
D, ¿eso es una D?
Sí.
Y después T en el Dover, ese.
Ajá.
Y después, ¿esa no sería la posibilidad?
Okay. This possibility, 50 over 14 over 50, this one, delayed and on time, this row, 50 over 14 over 50, is the possibility of not getting delayed and, I'm sorry, getting delayed and getting on time. No?
Mm-hmm.
6th Avenue and in Dover Avenue. But that is not the question. That is not the question. The question is, given that 14 over 50 is the first part, the and, the intersection. These little options in here give me intersections. So here, 14 over 50, I have the intersection of being delayed and being on time. That is the intersection. That is the probability of the intersection. But the question is not asking us for an intersection. The question is asking us for a conditional probability. The problem is if we just say that 14 over 50 is the option, this 14 over 50 is the part of the probability that we have this delayed and on time out of every single possibility, because there are 50 possibilities, over 50. But the question is asking us for a condition, so we have to cancel, we have to make the denominator smaller. We have to see all the possibilities. Out of all of the possibilities, out of the 50 possibilities, how many are taking that condition into account? So this one, 50 over 14 over 50, is not going to work because it is taking into account every single possibility, which means it's not taking into account the condition.
No.
Bueno, no pasa nada. Lo hago en españolito, listo, no pasa nada. A ver si de pronto eso mejora. A ver, ¿cómo lo pongo? Ok. En este caso, en 7 décimos y 2 quintos, ¿sí? Este 14 sobre 50. Ese 14 sobre 50 me muestra la probabilidad de que yo haya quedado tarde. Perdón. En la avenida Sexta, ¿sí? Y no haya llegado tarde en Dover. ¿Sí o no? Perfecto. Ojo a lo que estoy diciendo, ojo a las palabras que estoy usando. Tarde aquí y no tarde acá, ¿sí? Delayed y on time. ¿Listo? Eso es una probabilidad de una intersección por la palabra que uso. Y no puede ser la given that, no puede ser condicional. ¿Por qué no? Porque la condicional me está restringiendo todas las posibilidades, o sea, las condiciones. ¿Cierto?
Sí.
Ahora, ¿cuál es la condición? La condición es esta. ¿Dónde está mi condición? Ah, solo llego tarde en una sola vez, ¿cierto? Esa es la condición, solo llego tarde en una sola vez. La probabilidad era 23/50. Es que mira, de 50 posibilidades que hay, yo sé que hay 50 posibilidades porque ese es el denominador. Denominador siempre es el total, ¿no? Entonces hay 50 posibilidades. Hombre, no tenemos las 50 posibilidades acá porque el tree diagram es tan bonito que nos evita tener 50 posibilidades. Pero yo sé que hay 50 porque es el denominador. Miren, cada uno de estos casos el denominador es 50. Si hiciéramos esta probabilidad de acá, la probabilidad delayed and delayed, sería también sobre 50. Hay 50 posibilidades. Ahora, de esas 50 posibilidades, ¿cuáles cumplen la condición? ¿Cuáles? Solo 23. Estos 14 más estos 9. Esos 14 más 9, esos 23 cumplen la condición. ¿Cuál condición? Llegué tarde solo una vez. Esas son las 23 posibilidades en las que puedo llegar tarde. Por eso la probabilidad es 23/50. De las 50 posibilidades totales, 23 hacen que yo llegue tarde. 14 más 9. ¿Listo? Cuando haces una probabilidad condicional, tienes que delimitar el conjunto universal. Esto lo hemos visto en Venn diagrams. Por eso es que el diagrama no lo mirábamos grandote, sino mirábamos solo un pedacito, porque estamos delimitando el universo. Decir que esta probabilidad de aquí es la probabilidad condicional es un error, porque no he delimitado mi universo. Siguen siendo 50 posibilidades. O sea, no he mirado ninguna condición. Estoy mirando los mismos 50 totales. Tengo que mirar de los 50 posibilidades cuáles cumplen mi condición. Ese será el denominador. ¿Cuáles cumplen la condición? Pues ya dijimos 14 y 9. 23. De los 50, 23 cumplen la condición. Pero es que el nuevo denominador, pero es que no se ve, ahí. Por eso es que el nuevo denominador es 23. Ya el denominador no es 50. No tengo 50 posibilidades en total, solo tengo 23. ¿Cuáles? Las que cumplen la condición. Y de esas 23, ¿cuál es el éxito? Pues solo estas 14 de aquí. Delayed and on time. Solo esas 14. Por eso es 14/23. Una probabilidad condicional restringe el universo, el espacio grande de posibilidades. Mejor dicho, siempre que estés mirando a probabilidades condicionales, siempre el denominador va a ser más pequeño. Siempre. Por esa simple razón. Porque es que no todo el mundo, no todas las opciones cumplen la condición. ¿Un poquito mejor?
Sí.
Sí, o sea, yo sé que de pronto suena contraintuitivo, pero es que ahí está, o sea, delayed on time, 14/50, ahí está. Yo sé que de pronto suena un poquito contraintuitivo, pero la realidad es que este 14/50 no es la condición. Simplemente porque no he mirado cuáles de esos 50 cumplen la condición. Eso es lo primero que hay que revisar. Esos 14/50 es una probabilidad diferente. Es una probabilidad del total, no de la condición. ¿Mejor?
Sí.
¿Sí?
Sí, sí,
Right.
sí.
Hopefully, everybody else, if you were paying attention to this discussion that we had with Gabby and I, hopefully you guys get the idea, all right? But yes, at the end of the day, use the little formula. Maybe if you like to count, just like what I did, right? Looking at the totals, then looking at the condition. If you like to count that way, you can also do it. It is going to work as well. Let's continue with the last one. The last one. We have only 4 minutes. The last question. This one. Given that I get delayed, what is the probability that it was a 6 avenue? Ooh. So the first one, I get delayed. This is the condition. I get delayed. That is the condition. All right? That is the condition. I get delayed. Let me do it here. Remember, it is a conditional probability. So we have our little formula. We have The condition down and then the success on top, right? So what is the condition now? The condition is I get delayed. How many of these rows give me the possibilities of being delayed? If I take the first row, I get delayed for sure. I get double delayed. If I take the second one, I get delayed as well, right? If I take the third row, that is gonna make me get delayed as well, right? The only one that doesn't work is this one. All right, now I know that probability is, how much is this? 23, 29. That probability will be 21 over 50. No, that was dumb. 44 over 50. How do I know that? How do I know? That number is really small. Here, 44 over 50. Better. How do I know that is the probability? Simple. I just added the other ones. I said this one is good, this one is good, this one is good, this one is not, right? So this probability plus this one will give me 44 over 50. Look, 7 times 3. Look, let's do this multiplication. 7 over 10 times 3 over 5. This will be 21 over 50. If I add these 3, 21 plus 14 plus 9, 44. So the denominator now, the condition is 44 over 50. That is the probability of the condition, right? Now, let's continue with the part on top. What is the probability that it was at 6th Avenue? Out of all the probabilities of getting delayed, what is the one or the ones that made me get delayed at 6th Avenue? In this case, I don't have just one probability. I have two. Look, these are the three options that make me get delayed, right? But only two of these make me get delayed on the 6th Avenue, right? In fact, this one makes me get delayed on both. This one makes me get delayed on both. Let's read the question. Do we accept this one as a possibility as well? This delayed and delayed. Do we accept this one or do we not? Let me see the question. What is the probability that it was at 6th Avenue? All right. I would accept this one as a good option. Because if I get delayed on both, then of course I get delayed at 6th Avenue. Of course. So, the way I see it, the success will be 21 over 50 plus 14 over 50. In other words, the success will be 35 over 50. The addition of these two. Now that we have our division, all we have to do is do the mathematics. Just walk this inside of a calculator or simplify the denominators, 50 and 50. And we have a final solution, just like Medina said, 35 over 50. Let me write it here. 35 over 50. There you go. That is how do you use conditional probabilities for with a tree diagram. Now, guys, let me stop the recording here.